Ladies and gentlemen, welcome. My name is Pavel Bauer and I am a professor of the Delft University of Technology in the Netherlands, and I lead the research group of DC systems, energy conversion and storage. In this lecture, we will answer a few fundamental questions about electric vehicles. First question, what is an electric vehicle? Second, what are the key benefits of electric vehicles over fossil fuel powered vehicles? And third, how can an electric vehicle enable energy transition? First, let's begin with the definition of an electric vehicle. It is any vehicle propelled by an electric drivetrain taking power from a rechargeable battery or from a portable electrical energy source like fuel cell or solar panels, which is manufactured for use on public roads. The key point to be noted here is the electric drivetrain. That is what differentiates an electric vehicle from a conventional fossil-fueled electric vehicle where the drivetrain is mechanical. What is interesting to note is that the first cars were indeed electric in the end of the 19th and the early 20th century. In the meanwhile, fossil fuel powered cars with internal combustion engine became available in early 20th century. An intense competition then began between the two types of vehicles. As you may have correctly guessed, the fossil fuel powered cars won this competition due to two main reasons. Due to the poor battery technology, electric vehicle had a low range in those days and could never travel the long distances reached by a gasoline-powered car. Further, charging them took much longer than refueling gasoline. The second reason was that the mass production of cars like Ford Model T made gasoline cars affordable. With abundantly available and cheap fuels, fossil fuel-powered cars became the clear winner over the electric cars. As a result, the internal combustion engine cars has gradually dominated the market since then until this day. However, decades of research and development in batteries, motor and power electronic technologies have helped bring back electric vehicles to the forefront. We now have affordable electric vehicles with a 200-mile range that can be charged in less than an hour. 2 million electric cars are already on the roads globally in 2016, and this number is only expected to exponentially rise in the near future. Electric vehicles, shortly referred as EVs, have numerous advantages over conventional fossil fuel vehicles. Let's have a look at the four main advantages: sustainability, efficiency, convenience, and economy. The first one, sustainability. As most of you must be aware, the main driver for moving to electric vehicles is because they have no tailpipe emission, which reduces the pollution due to the carbon dioxide, sulfur oxides, nitrogen oxides, particulate matter, and improves the livability and air quality in our cities. Moreover, when electric vehicles are charged with electricity generated from the renewable sources, such as wind turbines or solar photovoltaic panels, the emissions due to the electricity generation are zero as well. Electric vehicles play a key role in the transition to renewable energy. This is because the main bottleneck for the expansion of renewable energy is the variability in the generation and the need for energy storage. Since electric vehicles are essentially a big battery on wheels, the electric vehicles can be used to store the surplus renewable energy by charging the electric vehicles with the solar energy in the day and wind in the night. In the future, there is another function that the electric vehicle is able to achieve called vehicle-to-grid or V2G. When the grid is overloaded in the peak time, the electric vehicle can feed their power back to support the grid. The second advantage is efficiency. Well-to-wheel efficiency is the specific life cycle assessment used for transport, fuels and vehicles, considering all energy losses right from the source of the fuel all the way to the wheels of the vehicle. The well-to-wheel analysis is used to assess total energy consumption, energy conversion efficiency, and emissions, including their carbon footprint. In this flowchart, we can see the well-to-wheel efficiency for both the electric vehicle and combustion engine that is calculated from the energy efficiency of each conversion stage. First of all, when comparing the efficiency of the vehicle from the fuel tank to the wheel, the efficiency of the electric vehicle drivetrain is around 85%, which is much higher than the 25% efficiency of the combustion engine vehicle. Secondly, the electric vehicle has a well-to-wheel efficiency of 35%, which is around 50% higher than the combustion engine vehicle well-to-wheel efficiency of close to 22%. This goes to show the far superior performance of the electric drivetrain. Further, this is a diagram which shows the well-to-wheel greenhouse gas emissions versus the total well-to-wheel efficiency and energy usage. Ideally, one would like to have a vehicle that is close to the origin, low on emissions and low on energy usage. From this peak, we can see that the gasoline and diesel engine footprint is located in the right upper corner, which indicates high well-to-wheel emissions as well as high energy usage. In the contrary, electric vehicles charged by wind and solar are located in the left-hand lower corner, and that means low well-to-wheel emissions and energy demand. Hence, we can conclude that electric vehicles have lower well-to-wheel emissions than combustion engine vehicle, irrespective of the type of electricity production, even if it is 100% coal-powered. Further, it is easier to manage emissions from the power plant, such as coal or diesel, as emissions are from a single source. Hence, electric vehicles are more health and environmental friendly than combustion engine vehicles. Moving on, the third benefit of electric vehicles is convenience. Electric vehicles have no gears and are much easier to drive than conventional cars. The lack of a combustion engine and mechanical drivetrain makes electric vehicle much quieter than their combustion engine counterparts, especially at low speed. You can charge your electric vehicle whenever you wish at home, just like charging a mobile phone. This provides the convenience of not having to go to the fuel station. Electric vehicles have a far lower number of components and a simple drivetrain in comparison with combustion engine cars. Hence, electric vehicles hardly require any maintenance. Only mechanical parts, such as bearings and brakes, must be maintained. Further, with the clever design, modern electric vehicles like the Tesla Model S have larger internal space with two boots, one in the front and one in the back. Moreover, electric vehicle would have complete self-driving capability in the future, opening a plethora of opportunities. The final category is economy. Even though the buying price of electric car is higher than a conventional gasoline car today, the total cost of ownership over the car's lifetime is lower for the electric car. Electric vehicles have a lower total cost of ownership, in short, because the lower maintenance cost, lower taxes, cheaper fuel, electricity, and due to a subsidy from the government. Even though electric vehicles have many advantages, it is also now faced with serious technical and economic challenges. I will highlight three of the major ones. The first two are related to the range anxiety of electric vehicle. First, electric vehicles require long charging times of a few hours, which is still much longer than the 2 minutes needed to fill up a fuel tank. Secondly, there is a limited charging infrastructure available today in public places and along highways. And finally, the capital cost of batteries are still high, which hinders the battery size, driving range, and cost of electric cars currently in the market. Hence, electric vehicles still have an enormous potential to be improved upon, both in technical and economical terms. As a conclusion, electric vehicles have made a comeback today owing to great leaps and bounds in battery, motor, and power electronic technology. The key benefits of electric vehicles are their zero tailpipe emissions, the possibility to sustainably power them from the solar and wind energy, their superior well-to-wheel efficiency, low well-to-wheel emissions, convenience in driving, and lower total cost of ownership.